This is a pre-built version of the application. So let's go ahead and run it. And the framework can use cities data coming from three places, either hard-coded or from the database or from file. And we will go over how to add, modify or remove cities data in all three places. And each city is identified by its latitude and longitude coordinates. And we are using the Haversine formula in order to calculate distances between cities. So in each route we start from one of the cities and then go through each city once and then return to the originating city. So let's try maybe using the hard-coded data first and maybe run in verbose mode. And here for the hard-coded data we have 8 US cities. So let's try finding the shortest route and maybe use brute force. And we have this number of permutations. So we have 8 cities in the route, so 8 factorial permutations. And all those routes here are equivalent. So if we start here from San Francisco, Denver, Chicago, it's the same as starting here from San Francisco, Denver, Chicago, and then going back to Boston, New York, Houston, etc. Or we could have gone this way, San Francisco, LA, Austin, Houston, New York, and Boston, etc. So they're all equivalent, and so this is the shortest route that we found with this distance in miles. And we started with this permutation that has this distance in miles, so we considered it as the shortest distance, and then we went to the next one, and this one now have this distance in miles, so it became the shortest distance. And we went to the next permutation and has this distance, and it is bigger than this one, so we kept this as the shortest distance. And then we came here, same thing, we kept this one, and here also we kept this one. And then here we found this distance, and it is shorter than this one, so now this became the shortest distance. And we kept doing this for all those permutations, and here we stayed with this as the shortest route. So we have this number of permutations. Next, let's try using data coming from file. So here we have 9 cities, and this is the cities file. So those 9 cities, and I have cities here stored, so we can use for convenience any one of the cities in those files, but the code accesses cities from here. So let's run in default mode. So and mute is the default mode, and we'll use data coming from file, and same thing, we'll use brute force. So it's not gonna show us all the permutations when it runs in default mode. So we have 9 factorial permutations, since 9 cities. Okay, so this is the shortest distance in miles, and all of those are equivalent. So maybe if we start from here to Toronto to Ottawa, so from here to Toronto to Ottawa to Montreal, and then we can go the other way around. And 9 factorial permutations is ends up being this number. So brute force becomes much more time consuming the more cities we add to the route, since we end up with much more permutations. And this is why it makes sense to use any one of the other algorithms if we have a huge number of cities. And let's do an 8 cities permutations again, but this time maybe use data coming from the database. So in the database we have these or those cities. So let's modify them to only keep 8 cities. So this is where we store the cities data. This is the database. So let's go ahead and delete it. And so let's close the application and delete the database. And then we have those 3 scripts that create the database, and we are using European cities. So and we have this script that creates the database. So let's just keep 8 cities. So let's remove those. And run this script, which created the database, and now let's go ahead and run the framework again. So we have 8 cities coming from the database. So let's pick database and do brute force. Okay, so here we go. This is the shortest route, and we have this number of permutations, 8 factorial. So currently in the code we have 5 different algorithms that can be used to find the shortest route, either brute force or genetic algorithm or simulated annealing or nearest neighbor or hill climbing. And we can easily add or remove to or from those 5 existing algorithms, and we'll go over this while writing the code. So let's try finding the shortest route using genetic algorithm. So let's see, maybe use the database data and genetic algorithm. So we did 30 generations, and we ended up with this as the shortest route. So this distance. So here they are sorted by fitness. So the highest fitness means the shortest distance. And let's do the same thing in verbose mode, just to show. So here we show all the generations. So we started with this generation, with this route, having the shortest distance in this generation. So this is the shortest distance, and each generation has a population of 8 routes. So we specify all of that. Mutation rate, population size, number of generations, all of that in here. So we evolved from one route's generation to the next using selection, crossover, mutation, and elitism. And we ended up with this route as the shortest route in this generation. And let's do the same thing but use hill climbing. So we found this as the shortest distance as compared So 5483 and 5439. And let's quickly go over how this works. So we started with this route having this distance in miles, and we compared it against the adjacent route, and this has a shorter distance, so we stayed, and we kept staying here for this number of iterations. And here we compared this route against the adjacent route. Actually, we are here. So we compared this route against the adjacent route, and this one had a shorter distance, so we proceeded. And the adjacent route has those two cities flipped. And here, same thing, we kept trying to find a shorter route, and we stayed here. For this number of iterations until here we proceeded, since this is a shorter route, and it has those two cities flipped. And here we stayed, etc. Until here we stayed for this number of iterations. So we consider this having reached a potential maxima, so we consider it as the shortest route found. So it's this distance in miles. And same thing, we specify that in here. So iteration before maxima is 100. And let's do the same thing, but use maybe simulated annealing. And we ended up with this distance, this shortest route. And here so the idea with simulated annealing is we start with a high temperature where we can easily make changes, and as the temperature decreases it becomes harder and harder to make changes until it becomes not possible to make changes. And in order to achieve that, we use this probability function, and we use this new temperature is equal to old temperature times 1 minus the rate of cooling, and we set this as the rate of cooling. So we start with this route with this distance in miles, and we take a look at the adjacent route, and the adjacent route has a longer distance, so we have to decide now depending on the random number and the probability function, and the random number is bigger than the probability function, so we stay. And same here. So now we are here, and now Same thing, we take a look at the adjacent route, and it has a bigger distance. So we check those two, the random number and the probability function, and the random number is smaller or equal to the probability function. So we proceed. So now we are here, even though this has a bigger distance than this. This is the difference between this and hill climbing. And we keep doing this. And just to show here, we take a look at the adjacent route that has those two cities flipped, and the adjacent route has a shorter distance, so we go ahead and proceed. And same thing here, we have this distance, so we proceed, etc. Until here we can no longer make any changes. So we ended up with this as the shortest route found with this total distance. And let's do the same thing, but now use nearest neighbors. So we ended up with this as the shortest distance. And here we started with this initial route, and we randomly picked a city from here, so it had this total distance. So we picked this city randomly, and then we checked the distance from this city to each one of the remaining cities, and we found that this city has the shortest distance to this one. So now we are in this city, and same thing, we check which one of those has the shortest distance to this one, and it turns out that this city does. So now we have those three cities, and same thing, we check which one of those has the shortest distance to Paris, and it is this city, etc., until we have no longer cities remaining. So we end up with this as the shortest route with this total distance. And this source code will be available for download. Also a longer version that includes coding and test running the coded application will be available for viewing by channel members at the senior developer level and above.